We've got some word problems that we need to do, and they're pretty much classified in three different types. The first one we're going to look at is called motion problems, where you're in the water, you're in an airplane, you're driving. Normally motion problems start off with what I've got here in the little yellow box. Distance equals rate times time. Just suppose you were driving 60 miles per hour in your car and you go for 2 hours. Now, assuming we can stay 60 miles per hour, then the distance you have traveled in that time would be 120 miles. So this is where this formula comes from. These problems that's in this book, pretty much the time traveled is always the same. So instead of using D equals R times T, we divide both sides by R, and this is where this formula comes from. So distance divided by rate will give you the time traveled. So this is the formula that you need to know. So in our example here, in still water, your small boat averages 8 miles per hour. So if you do not have a current of any sort, you go 8 miles per hour. But now if you get in a stream or a river, and in this particular situation it says it takes you the same amount of time to travel 15 miles downstream with the current as 9 miles upstream against the current. So notice the time going downstream and coming upstream are the same. My unknown here, or what they want me to find, is what is the rate of the water's current. I don't know that. So when I define the variable, I'm going to let x equal this thing I'm trying to find. So x is going to be the rate of the water's current. So in these, it does help if you make out a table. Now in this table, I've got, with us going with the current and without the current. Now the distance that we travel with the current, which is downstream, is 15. So right here, I'm going to have 15. Without the current, they told me going upstream would be 9. Okay? My rate, well, this is where this, the rate of the water's current, comes into play with how fast your little boat goes when it's not in the current. So going downstream with the current, remember my boat can go 8 miles per hour, but when it's aided by the current, then it would be 8 plus x. Without the current, I'm fighting it, I'm going against it, so that would be 8 minus x. So I've got to have the 8 in front, alright, because this is I'm being aided and this one it's fighting me. So the time traveled. So let me make my little distance over rate of travel. I'm going to have 15 over 8 plus x, but I have a little t sub d where this is going downstream, so I know I'm going with the current. And in this one, going upstream without the current, I'd have 9 over 8 minus x, and that would be that part. Now remember, it says it takes you the same amount of time, so these two times would be the same. So solving the equation would mean I would set these two equal to one another. So substituting in, here's my time going downstream, time coming upstream. Now we didn't really have any problems like this in the last section when I have one equation equaling one equation, but you'll find out it's quicker if you do cross multiplication to do these problems. It works the exact same way of getting a common denominator, but it's faster. So I'm going to go 15 times this, 9 times this, distribute through. You should end up with that. Get your numbers to one side, variables to the other, so it looks like by this I move my numbers to one side and that 15x to the other. Now divide both sides by 24, and my x is 2. Now remember what that is. That's the rate of my current. So to check this, I put 2 back in. Let me store 2 in for x. I've got 15 divided by 8 plus x, and 9 divided by 8 minus x. Notice they're the same thing, so it does check. My sentence answer, well, I've got to answer the question, what is the rate of the water's current? Well, the water's current is going at 2 miles per hour. So there's that one, and this is a distance or a motion problem, okay, involving time. Now the next one I'm going to look at is a work problem. These are interesting because we have another little formula we have to have. So A is equal to the time it takes one person, person A, to do a job alone, and B is the time it takes another person, say B, to do a job alone. X represents the time it takes for A and B to complete the entire job working together. Then the situation can be modeled by this rational equation. Okay, so X is the together time, and A and B are the individual times. So in this problem, you can design a website in 30 hours. Your friend can design the same site in 20 hours. How long will it take to design the website if you work together? Alright, well, if I use this, my unknown, the question was if we work together. So X would be the time it would take for us to work together. Okay, write and solve the equation. Okay, so I'm going to have x over 30 plus x over 20. Whoa, let me move this down a little bit. Common denominator would be, what, 60? So we're going to multiply all my terms by 60. And now I get to cancel. So 30 into 60 would be 2, so I'd have 2x here. The next one I'd have 3x equals 60. So there's all my canceling. And if you remember, I always do my leftovers. So 2x plus 3x gives me 5x. 5x equals 60 divided by 5. X should be 12. My check, well, let me store 12 in. I got x over 30, x divided by 20, and it equals 1. So I said try it in your calculator. I just did, and I know it works. So my sentence answer on this one would be, since x is time to complete the job working together, it would take us, if we could work together, 12 hours. So if they both work together, it should take 12 hours to design the website. Okay? So that's it for the first two. I'm going to do another video for the last two. Alright? Thank you.